Today we are going to take a look at converting units. We are going to go over different units of measures and how to convert from one unit to another, as well as which unit is appropriate for different scenarios. To start with, let's take a look at a couple of different situations and determine which unit of measure would best apply to that situation. If we begin with the distance from New York to Los Angeles, whenever you have to decide which units you should be using, you want to take a minute and think of what you're dealing with. If we're looking at the distance from New York to Los Angeles and had to choose between feet or miles, the best unit of measure would be miles, because the distance from New York to Los Angeles is a pretty big distance, so we wouldn't want to use feet. Miles would be the much better option. We also have another scenario here looking at the length of a pencil. When considering the length of a pencil, what would be the best unit of measure, inches or feet? Inches would be the best unit of measure for this one, because we would be talking about something that wasn't too big in length, so for a pencil, inches would be our best choice. If we used feet, it just wouldn't be as good of a unit of measure to use given that object that we're focusing on. So whenever you're dealing with different units of measure, you want to really take a minute and think about the scenario, think about the object, think about the distance being discussed, and really pick which unit you think would best apply to that situation and give you the best picture of the distance or length that you're trying to look at. Another topic covered regarding units was the scaling of graphs. It's very important when you're given different scenarios that when you go to graph it, you really take a minute to set a good scale on your graph so you can get an accurate representation of the situation that you're dealing with. So one thing with graphs, you always want to make sure when you look at it that you take a look at the scale to see if they're going up by 1, if they're going up by 5. You want to make sure that you're reading the graph appropriately. And in this case, we're going to look at two different graphs here, and one of these is better than the other with how they're representing the data. So they're both actually showing the same data, but one of the graphs does a better job of spacing everything out so that you can get a better picture of the scenario. Sometimes, depending on how you graph data, the graphs can be a little bit misleading if you don't properly scale your axis. So in this one, if we look at this right here, so if we start with this one, we can see that the way they have them spaced out, we have it starting here along the x-axis and it runs like this, but if you notice the y's are going up by 5s, so every box here represents 5 units. With the x's, every one represents 1 unit. So when they were going with the x's, that was a pretty good representation of x. It's spread very well horizontally. But when it comes to the vertical, all of my data points fall within the first box here. So that's not doing a very good job of scaling my y-axis. So if we look at this graph over here, they did a much better job. They went up by 1s on the y-axis and also 1s on the x-axis. So the data is much more spread out, which gives me a better representation of what's actually happening here. So you can see it starts at 0, 0, and then it goes up to 1, 1, 2, 2, 3, 3, and so on. This graph here has the same exact data points. This is just a better scaling and a better representation. So whenever you go to graph something, really take a minute to think about how you're going to scale your graph. Sometimes instead of having the x-axis be good and the y not be working, you may see graphs where the y is spread out properly, but all of the x values are kind of pushed together really close, so you don't get a really good picture of everything that's happening. So this graph over here would definitely be the best representation of this data because it gives me a really good picture and I can really kind of see a good spread of what's happening in that situation. Another topic that was very important in this unit was converting units. So we're going to take a look at 3 different problems to help you look at different situations and different units of measure and how to convert from one unit of measure to another. So to start out with this, we're going to look at converting 10 miles to inches. One of the first things we need to do is think about what the conversion would be that I need to use for this. So we need to think about how to get from miles to inches. and I'm going to put some little helpful hints here that you may want to write down and take note of. We have the fact that 1 mile equals 5,280 feet. Now that would help me get from miles to feet, and then I'm also going to need to be able to get from feet to inches. So we know that 1 foot equals 12 inches. Whenever going through these, you might want to make sure you get a list of some of the popular conversions that you're going to need to use so that you can set up your ratios. And then what we're going to do, I'm going to set up 10 miles, and whenever I do these, I put this as a fraction. So I'm going to have 10 miles over 1. I'm going to make it a fraction because that makes it easy to go through my conversion. So I have 10 miles over 1, and I'm not going to put any units on the bottom because there aren't any there. And then in order to get from miles to inches, I first need to take a step where I go from miles to feet. So I am going to multiply, and I'm going to set up another ratio here. Whenever you do conversions, you're going to use ratios. So to go from miles to feet, I need to first go and look at my conversion. So I have 1 mile equals 5,280 feet. When you go to do this, I need to set up this ratio so that the miles are going to cancel out. So I need to look and see where I would need to put them on this fraction so that they will cancel out with the miles from the 10 over 1. And I'm going to need to put them on the bottom. So I am going to have 1 mile on the bottom. And then on top, I'm going to have what that was equivalent to in feet, which was the 5,280. Now that will get me to feet, but my end goal was inches, so I am going to go ahead and do this all in one step here, and I'm going to add another ratio. And this time I'm going to go from feet to inches. So again, I'm going to look at this ratio right here, and I'm going to figure out when I go to set up my new one, where do feet need to go on it to cancel out? Well, since they're on top here, I need them to be on bottom of my new ratio. So I'm going to set it up with 1 foot on the bottom and 12 inches on top. Now what's going to happen here, and if you wanted to, you could write this all out as one fraction and have all of the numbers from top over all of the numbers on bottom. At this point, I can go through and I have miles on top here, and I have miles on bottom here, so those are going to cancel. I have feet on top here, and feet on bottom here. So the only units I'm left with on top are inches, and I have nothing on the bottom. So what I'm going to do at this point is on the top, I am going to have 10 times 5,280 times 12 inches. My little multiplication symbols in here. And that's over, on the bottom, we just have 1 times 1 times 1, which is going to just end up being 1, but we'll write them out anyway. And then I am going to go ahead and type that all in the calculator. So I would do 10 times 5,280 times 12, and on the top I am going to be left with 633,600 inches. And that's over 1, so I could just leave it as the 633,600 inches. And it's a very large number, but you also have to think that we went from miles to inches. And going from miles to inches, that's going to take quite a few inches to cover 10 miles if we were going to do that. So my final answer for this one would be 633,600 inches. And this is going to hold true whenever you're doing conversions. Miles to inches, cups to gallons, all of those are going to involve the same process here. You're just going to have different conversions that you use. Now the next problem that we're going to look at is also going to involve converting units, but this time we're going to go from 29 miles per hour to feet per second. So we're going to be dealing with speed here. And we're going to follow the same exact process that we did before, except instead of just doing something like miles to inches, we're going to need to do miles per hour to feet per second. So that's got a couple different numbers we're going to need to convert. We're going to need to deal with the miles and the hours, and it's going to have a couple extra steps added to it, but the same process as what we did before. So to start, I'm going to set this up the same way, but it's going to be a little bit different than the last one looks. So we're going to have 29 miles per hour. So when I go to set this ratio up, I'm going to have 29 miles over 1 hour. So 29 miles per hour, and I need to go to feet per second. So we are going to need to use our conversion, and we're actually going to use the same one that we just did. So I figured we would stick with miles since we just went over that. So we had 1 mile equals 5,280 feet. And then we're also going to need to do hours per second, but those are conversions that are a little bit more common, so I'm not going to list all those up here. I'm just going to put this over here. So 29 miles per hour. Now we need to change the miles to feet and the hours to second. It doesn't matter which one you start with, so I'm going to start with the miles. So what I'm going to do is I'm going to set up my ratio, just like we did on the last one. And I am going to figure out if I wanted to make miles cancel out, where would I need to put it on my new ratio, my new fraction? I would need to put it on the bottom. So on the bottom for this one, I am going to have 1 mile, and on the top, I'm going to have 5,280 feet. I am then going to multiply that, because this is now going to let the miles cancel out. My goal was to get to feet, so we've actually accomplished that now. And now I need to make the hours into seconds. So that's going to take a couple extra steps. So I am going to go and set up another ratio. And my hours are on bottom. I need to make them cancel out. So instead of just jumping from hours to seconds, I'm actually going to go from hours to minutes and then minutes to seconds. You could at this point go from hours to seconds if you knew how many seconds were in an hour. I'm just going to do this extra step here so that you can see how this would work if you didn't know that. So for every hour, I would have 60 minutes. So in order to make the hours cancel out, I'm going to need to have it on top. So I'm going to have 1 hour has 60 minutes. And that is going to now let my hours cancel out. Now I need to go from minutes to seconds. So again, same process. We know that 1 minute has 60 seconds. So the minutes now, when I set up this ratio, would need to go on top. So I am going to have 1 minute per 60 seconds. And that is going to now let me cancel out the minutes. So when all is said and done with this, I should have feet on top and seconds on bottom, which is exactly what I have left over. And now at this point, we need to just get our calculator out and we're going to type some numbers in. So on the top, I am going to have 29 times 5,280 times 1 times 1, and the only thing left is feet, over 1 times 1 times 60 times 60, and the only units down there are seconds. So we're going to go plug these into the calculator. You guys grab your calculators and plug them in and make sure that you are getting the same answer as me. Put up my multiplying symbols. So on the top, I am going to have 29 times 5,280 times 1 times 1, and that will come out to 153,120 feet. And that's going to be over 1 times 1 times 60 times 60, which is 3,600 seconds. And this is not going to come out to a nice number. It's going to come out to a decimal. So I'm going to type this in at this point in the calculators to 153,120 divided by 3,600, and that's going to give me my final answer. So again, it does come up to a decimal, so I'm going to round this, but you should get 42.5, and then it has 3 repeating. So you have this little symbol on there to represent that. All right, so the 3 would be repeating. And then my units are feet per second. Feet per second. And that's my final answer, 42.53 feet per second. Hopefully this has helped you to better understand how to do conversions and how to tell which units of measure to be using. And I hope that you had your questions answered. Thank you.